Oh, wrong notes. Hi, everybody. How are we doing today? All right. So folks playing along at home, I am going to start recording the warm up and the homework as well. So you might see a little bit extra at the beginning, but I just thought it would be a good idea for you to get the whole class rather than just the lesson. You see the warm up, you see us going over the homework, and then the lesson as well. All right. So let's talk through this warm up. Okay, so again, if you're playing along at home, it might be a good idea to pause now, do the warm-up, and then play when ready. All right, so remember that when I find the solution to a system, I'm finding where the two lines will cross, right? I'm finding where the two lines will cross. So I'm just going to graph both of them separately on the same coordinate plane. Remember that for this first one, what's my slope for this first one? What's my slope? 2. Right? 2. The y-intercept is 0. Okay? It goes through the origin. Right? If you don't see a b value, it's not there. It goes through the origin. So it goes through 0, 0. And then so that means I have a slope of 2 going up 2 over 1. Now remember, make a lot of dots. You don't know where the other line is going to end up. So make a lot of dots. You could go down and to the left or up and to the right. So there's my line. Then I go to graph my other one. Now my other one, what's my slope? You know, let me pull some names. I haven't talked to some people in a while. This is second period. Joey, what's my slope for this second line? That's my b value. Good. So that means I go down to my y-intercept to -4, and I use my slope of 1. Now, I would go up 1 over 1, but isn't that only going to get me further away from my other line? So let's go down 1, left 1. Boop, right there, found it. Yeah, if you use sound effects, it actually makes it better. So there's my location. -4, -8. Is my solution. -4, -8. Notice that my second line can be small. I don't care very much about my second line. Again, I don't really care where the line ends up. I just care where the intersection point is. I care where it crosses the other line. Okay, so let's take a look at the next one here. Number 2. There we are. Come on now. Ben, there we go. Ben, what's my slope for this blue line up top here?
3.
And what's my y-intercept?
-4.
Good. So that means I go down here at -4. Remember, again, guys, I'm still having so many people put the y-intercept on the x-axis. Please, people. The y-intercept goes on the vertical axis. So -4 is my b value, and then the slope is 3. Rise 3, run 1. Rise 3, run 1. And again, make a lot of dots. You don't know where the other line is going to end up. Down 3, left 1. And then there's my line. Now, this second line. What do I have to do to it? Before I start graphing, somebody tell me. What do I have to do to it before I start graphing? Carson? Good. Move the 8 over to the other side. And subtract it over to the other side. So it's y is equal to 5x minus 8. Therefore, my slope is 5. My y-intercept is -8. So I go down here to -8. My slope is 5. Up 5, 1, 2, 3, 4, 5 over 1. Up 1, 2, 3, 4, 5 over 1. Look, crosses right there. So that means right there is my intersection point. Where is that location? 2, 2. And that's my answer. Questions about that? Okay, we still have not gone over the answers for this page 386, 9 to 16. So I'm going to show the answers for that. There's 9, 10, and 11. This was due last Wednesday. This was due the day that we had that catch-up day. So if you did not do this, make sure you turn it in, because I'm taking this one for a grade. Yeah, take a look. It's page, I forget what page it is, but it's 9 to 16.
I thought some of this got in this way.
I would save everything until the exam.
Say what?
You can make a, you can clean out your binders after the exam.
Everything's going after exam.
Everything.
Everything.
And even tests.
Yep.
Wow. That's bold move. So number 9 is a no, number 10 is a yes, number 11 is a yes. Remember, all you're doing there is you're plugging in the values. You're saying, is that point the solution? Yes or no? How do you tell? Well, you plug it in. Okay. And you're seeing it plugged in for equation 1 along the top row, and then equation 2 along the bottom row. Any questions on 9, 10, or 11? Okay, let's keep scrolling here. There's 12. The answer for 12 was negative 2, 1. Check your graphs as well. Chances are that if you messed up these, you probably just did the wrong slope, positive to negative, or maybe you put the y-intercept in the wrong spot. Maybe you did it for an x-intercept instead of a y-intercept. So again, for number 12 should be negative 2, 1. Here's number 13, should be 3, 3. Number 14 should be negative 4, 7. Let me flip it over to the next page here. There's 15. The only catch with 15 is that you had to subtract the x over to the other side. So the slope was negative 1, the y-intercept was 2. And then here's number 16. So number 16 was a word problem. We didn't really talk through any word problems the last week, but this one was still, not too bad. The first person, X was weeks and Y was the number of miles, right? So the first one started out at 7 miles and was going 1 mile a week. The other was started at 4 weeks, X is weeks. So 7 weeks and then 1 mile per week. And then 4 weeks and then 2 miles per week. So how long would it take for them to reach the same amount of miles? That's what we're looking at here, right? You're going to find that once we start today's lesson, we're going to be moving into more of an algebraic way of solving these. Graphing, because the numbers get so big, is not really plausible a lot of times. In this case, they are, because the slopes and the y-intercepts are pretty easy numbers. But you just see where they cross. It looks like they crossed at, what was that, 3 or 4 comma, no, I had it right the first time, 3, 10. So the answer is, in 3 weeks, the mileage will be the same at 10 miles. Okay. And that is it for today. So, as you'll see on the board, and the folks at home probably saw on the agenda for the week, we're going to have a quiz on Thursday. And the reason behind having a quiz on Thursday is to try to give you guys another assessment in the grade book.
It's me and Joey's mom.
You know everything you say is recorded. You know everything you say is recorded, right?
Yes.
Okay. So we're hopefully going to get you another grade in the grade book before the exam time. Well, not hopefully, we are going to get you another grade in the grade book. Because think about this. Shh, quiet, folks. Think about this. We do section 6.1 and 6.2. We'll have a quiz on Thursday. We've got 1 more week. before we start exams. Okay? We've got one more full week before we start exams after this week. So basically what we're going to be doing is sections 6.3 and 6.4, and then we'll take our chapter 6 test. Okay? So we've got one small quiz that we'll do on Thursday. It's really only like 25 points. It's not very big at all. We'll actually review a little bit before we take the quiz. We've got one more quiz this week, and then we'll take our chapter 6 test. And after that, we're just going to be doing exam review. We're just going to be doing exam review. So there's only a couple more grades that go in the grade book for before the exam time. So we've got to talk about section 6.2 then. Now, if I ask you to solve, like, if I go like this, let me show you something. Take a look up on the board here real quick. If I asked you to solve this system, oh, come on. There we go. And I said, okay, we got this line, y-intercept of 2, slope of 1, okay, something like that. And then we've got a y-intercept of -2, and then a slope of -3/2. Your brain doesn't know like where to draw the line straight. Yeah, I have to go like this. It's just years and years of preparation. You know, and I kind of drew that almost a little bit like it looks like it would be at a decimal. Okay.
The first one looks perfect.
You know, I thank you. My whole life is all perfect. Hey, where would be my intersection point? Well,
what looks like -1.5.
But exactly. I want to know my intersection point exactly. 2. No, between the two lines. Find where the lines cross. Can I tell exactly where the two lines cross? No. So what happens when we have a case like this? Because not every two lines will cross at a nice, neat point. So in section 6.2 and 6.3, what we're going to be looking at is, what happens if we have a case like this? How do we solve it? Or maybe we don't have the ability to graph. Maybe it's a difficult equation that we can't actually graph. Presented in a way that it's easier to solve algebraically than to try to figure out how to graph it. So we have to figure out more algebraic methods. One of those methods is called substitution. The other one is called elimination. Section 6.2 is about substitution. Section 6.3 is about elimination. All right, so let's talk about what's called substitution. Again, sometimes it's difficult to identify the exact solution by graphing. In that case, we have to use what's called substitution. These are your steps for substitution. First step, solve one of the equations for one of the variables. Solve one of the, and these are outlined for you on your guided notes. Solve one of the equations for one of the variables. So basically what I'm saying there is get y alone or get x alone. Whatever is easier. A lot of people are always like, well, I gotta get y alone because that's what we always do. No, you don't have to do that. You can get x alone if you need to. There are going to be a lot of times when that is done for you. Step 2, take what you got in step 1 and plug it into the other equation. So you know that variable that you solved for? Take what you solved for and plug it into the other equation and solve that equation for that variable. And then my last step, you're going to get x or y is equal to a number in step 2. My last step is to plug my answer from step 2 back into one of my equations and solve. Let's try it here. Okay, everybody should be doing this along with me here. This first one, y is equal to 3x and y is equal to x minus 2. Could I graph this? I mean, these are both set up to graph, right? I would be able to graph this unless the direction said solve the system by substitution. To check my answer, I could graph it just to make sure. But I've got y is equal to 3x and y is equal to x minus 2. Do you guys see how they're both set equal to y? They are both y equals equations. So here's what I can do. Substitution says that, well, take a look at equation 1. equation 1 says that y is equal to 3x. So what I'm going to do is I'm going to remove y out of the equation 2. And in its place, I'm going to write 3x. Okay? That's substitution. Right? You remove something, you put something equivalent in that place, that's called a substitute. Right? That's where it gets this name. So here's what I'm going to write here. I'm going to say 3x is equal to x minus 2. And now we've created an equation that we can solve pretty easily. Remember, to get rid of the little guy, I subtract the x over to both sides. That gives me a 2x is negative 2. I divide by 2. That gives me x is equal to negative 1. Now, remember, don't lose sight of the end goal. The end goal is to try to figure out what location these lines will cross. So I'm going to start my answer now. I'm going to say it's negative 1 comma something. Well, how do I figure out what the y value is? Well, I just plug it back into one of my equations. Let's say y is equal to 3x. I'll just take my first equation from my system. Well, y is equal to 3 times negative 1. So negative 3. And there's my answer. Questions about that? Can we try another one? Okay. Is step 1 done already again? Yeah. Look at my top equation. Look at equation 1. Isn't that equation already solved for y? Isn't that equation already solved for one of the variables? So here's what we're going to do. We're going to take our other equation. So this is equation 1, this is equation 2. We're going to take equation 2. I'm just rewriting it as it is for our purposes here. I'm going to take equation 2. I'm going to remove y, and in its place, write something equivalent. Well, what is equivalent to y? X plus 1. Y equals x plus 1. Usually we plug it in with parentheses, but that doesn't really mean anything here. Like, I don't really have to put in parentheses. What do I mean by that? I mean by that, like I normally plug things in parentheses like that. But I would like distribute a positive sign. That doesn't really do anything for us. So we solve. 4x and 1x make 5x. We subtract a 1 over to the other side. When we divide by 5, we get x equals 1. We take that 1 and we plug it back in. Where do we plug it back into? Well, I think if I'm trying to solve for y, I know I've got x is 1. I'm trying to figure out what my y value is. I mean, don't you think the first equation is really easy to plug x into? Y is equal to x plus 1, so y is equal to 1 plus 1, or 2. Questions about that? So those two examples are when one of the equations was already solved for one of the variables. It was kind of what I would like to call set up for substitution, because one of the equations was already solved for one of the variables. Is that the case here? No. What What kind of form are both of these in? These are standard forms, right? X, Y, constant. Okay, let me ask you this then. What's the easiest equation? And which variable is it going to be solved for? Which variable is the easiest to solve for? And in which equation? Equation 1 or equation 2? Perfect. Good. Why do you say that? You're right. Why do you say that in equation 1 it's easiest to solve for x? Exactly. We all see that? X is alone. Once we solve for x, once we move that 6y over to the other side, there's nothing to divide by. Always look for that. He said solve for x in equation 1. So let's do that. We had x plus 6y is equal to 11. Because it doesn't matter whether I solve for x or y. It does not matter when you're doing substitution. Graphing, it matters. You have to solve them for y. You have to put them into slope-intercept form. But for substitution, it doesn't matter. So let's just subtract the 6y over to the other side. And guys, it doesn't even matter what form it's in. Like, you don't need to put the y first or anything like that. Just write it as 11 minus 6y. Okay, now, we had equation 1. We manipulated equation 1. So now I have to plug that into equation 2. Okay? This goes in for x in equation 2. Do not lose the 2. Because again, it was 2x plus 3y is equal to negative 5, right? So now, instead of 2x, it's going to be 2 times, I'm going to remove the x and in its place write a substitute, 11 minus 6y. Does everybody see what I did there? In equation 2, I took out x. I removed x. See, it was 2x plus 3y is equal to negative 5. I took out x, and in its place, I plug in 11 minus 6y. And notice that I keep the 2 up front that was originally in equation 2. And now I just solve for this equation here. I solve for y here. I distribute the 2 in. This gets me a 22 minus 12y. Be careful here. What's my next step? Carson? Like terms. What do I get when I combine the like terms? Negative 9. Good. I'm glad we didn't say negative 15. A lot of people might try to tell me negative 15. Negative 12, positive 3. We subtract the 22 over to the other side. This gets me a negative 9y is equal to negative 27. And we divide by negative 9. Y is 3. Okay, now we're cooking. We got one of the 2 variables. Once we hit this point, it's like dominoes are falling. All I need to do now is find out what my x would be. Well, guys, take a look up at this equation right here. X is 11 minus 6y. So x is 11 minus 6 times 3. I already created myself an equation that solves for the variable that I want to find. Don't do more work than you have to. So we've got x is equal to 11 minus 18. Or negative 7. My final answer, negative 7, 3. That was a lot of work. I will tell you right now, that's probably one of the more difficult substitution problems, when neither of them are solved for. Okay, that's when it's the hardest it could possibly get for a substitution. Okay, let's do one more of those so we see how it looks. Do one more of them. Negative 2x plus y is equal to 8. 3x plus 2y is equal to 9. Okay, somebody tell me what's the easiest equation, or what's the easiest variable, and in which equation is it easily solvable in? Bigger.
Y in the top equation.
Y in the top. Good. Y in equation 1. So here's equation 1. Negative 2x plus y is 8. What do we do to solve for y? Carson? Just add 2x over the other side. Dividing would be breaking apart the 2 in the x. So y is equal to 8 plus 2x. Could I say 2x plus 8? Sure. Does not matter. Okay, now, take a look at equation 2. I'm going to take y and replace it with this 8 plus 2x. And I'm only replacing the y. I'm not replacing the 2y. I'm only replacing the y. So this becomes 3x plus 2 times 8 plus 2x is 9. I distribute in the 2. (16 plus 4x). I combine the 3 and the 4 to make a 7. I subtract over the 16. And I get negative 7. And look at that. X is negative 1. My last step is to take that negative 1 and plug it back right into there. Y equals 8 plus 2 times negative 1. Y is equal to 8 minus 2, or 6. If I were to go and graph these, I would see my location where they cross at negative 1 comma 6. Questions about that? Oh, that's not too bad. 2, 6, 9, 11, 13, 15. Last thing that we got to do here is take a look at a word problem. One cable TV provider has a $60 setup fee and $80 per month. The second has a $160 equipment fee, but charges $70 per month. Okay, so one is a less per month. The other one charges more up front. And how many months will the cost be the same, and what will that cost be? Okay, well, let's try to create a system. Let's try to create an equation. What's my first company's equation? $60 setup fee, $80 per month. What would that be? Somebody tell me. $60 setup fee, $80 per month. Baker.
60x plus 80, or 80x plus 60.
Good. Y equals 80x plus 60. So obviously the other place, y equals, okay, 70x, $70 per month. Well, they charge us $160 setup fee. Now, I think you guys would agree with me. I do not want to try to graph this. Right? Y-intercept of 160, slope of 70? No, thank you. So I would hope that there's an easier algebraic way. Oh, look at that. They're both solved for y. When they're both solved for y, you can set them equal to one another. You can take this 80x plus 60 and plug it into the other equation for y. 80x plus 60 is equal to 70x plus 160, because I want to know when the cost will be the same. We subtract the 70x from both sides. We get 10x plus 60 is equal to 160. We subtract 60 from both sides. We get 10x is 100. We divide by 10. X is 10. And then I could just plug it back into one of the equations. Let's go into the top one. 80 times 10 plus 60. So y is equal to 800 plus 60, or $860. Okay, so what's my final answer? And how many months will the cost be the same? 10 months. What will that cost be? $860. You know, my last question asks what the OST loves to ask. If you plan to move in 6 months, which is the cheaper option? Which is the cheaper option? Company 1 or company 2? Company 1. Wait, are we sure? Let's plug 6 back in. 80 times 6 plus 60. Let's plug it into the second place. 70 times 6 plus 160. Oh, yeah, you're right. I'm sorry, you're right. Brain fart. Yeah, the other one's got the lower startup. So company 1 would be cheaper. All right. So long, everybody playing along at home. Stay healthy. See ya.